All right, so this computation is probably one of those things you need to do at least once in your life, especially if you're a mathematician who does analysis or somebody who does statistics or probability. And this is showing the area underneath the curve of the Gaussian is square root of pi. What we're going to do is we're going to end up showing that the integral from minus infinity to infinity of e to the minus x squared dx is equal to the square root of pi. Now, the square root of pi, we don't know this yet, so I'm just going to call this integral I. We're going to find I, but to find I, what I'm going to do is I'm going to square I first. This is equal to this integral times itself, but I'm going to do a little relabeling. I'm going to write this as e to the y squared dy. You know, this is just internal variables, so it doesn't really matter what you call them, but what I can do now is I can combine these two guys to make this integral here. So I'm going to have the integral, the double integral of e to the minus x squared y squared, or minus x squared plus y squared dx dy. So now this is an integral over the plane, r squared. First integrated x, and then integrated with respect to y. What I'm going to do is I'm going to change this from being a rectangular integral to a polar integral. And so I'm going to switch it to being from x squared plus y squared to r squared. And so that's just going to represent a radius coming out from the origin. And then I'm going to integrate that, and I'm going to sweep in a big circle to give me integration over theta. So it's going to turn into the integral from 0 to 2 pi for theta, the whole circle, and integral from 0 to infinity for r. And that's a radius going from the origin out to infinity. This ends up becoming e to the minus r squared. And then we're going to get dr and d theta, but that's not quite it, because we also need that r term from the Jacobian. That's actually something we can incorporate here with a u substitution to actually get a concrete value for this integral. And then the outer integral actually has nothing to do with r, so we can just go ahead and do it, and that's going to pop out 2 pi. And then I'm going to make a u substitution of u is equal to r squared. We have now integrated with respect to theta, so is 2 pi. Change this to an improper integral, limit from b to infinity, of this guy, and then I use the u substitution r squared is equal to u to pop out this guy. So the integral bounds are now from 0 to the square root of b, and we have simply the integral of e to the minus u. And so then we end up getting e to the minus square root of b minus e to the minus 0, and then we're going to have that minus sign popping out, so it's going to flip those signs. And then when we put everything together, we take limits, well, this term here is going to end up going to 0. And so that one will end up vanishing, and this guy is just 1. So we end up ultimately getting is we get pi times 1, and but this was I squared. And so then we get I is equal to square root of pi.